Hello, in this video, we're going to be talking about the product and quotient rule. If you are adding inside of a derivative, you can just derive those two sums or differences. However, with products and divisions, these do not work. It is not quite like that. We'll start with the product rule. The way the product rule works is this thing down here is how I would say that. You do the derivative of whatever your first thing is in the product times your second thing plus the derivative, whatever the second thing that was getting multiplied by, times the first. So the derivative of the first times the second, plus the derivative of the second times the first. Here's an example of the product rule in action. So I did the derivative of my first thing. I got a 3 times the second thing. Plus, it's always going to be a plus here for product rule. The derivative of the second thing, which is 3x squared, and then I multiplied it by the first thing. We could simplify this down if we so felt inclined. Do a little distribution, we get that stuff, and then combine like terms, and then boom, there's the derivative. Let's do one together. So I want to figure out what the derivative of this thing is. So I need to do the derivative of that first piece. So the derivative of this x, well, that's just going to be 1 multiplied by whatever the second thing was. In this case, an ln of x. Plus, and I'm still just working on this piece right here, I need to do the derivative of the ln of x. Well, that's 1 over x. And then multiplied by whatever this first thing is. So that's x. It is only now that I'm able to move on to this second piece because all of this that I've done right here is the first part, the derivative of x ln of x. But then after that, you can just do regular old derivatives. What's the derivative of minus x? Well, that's just minus 1. We could simplify this down a little bit. So then y prime is going to equal 1 times the ln of x. Well, that's just ln of x. Plus 1 over x times x. Well, that's just 1. And minus a 1. Oh, well, hey, that's just 0. So y prime is just going to be, in this case, the ln of x. In this example, I want to employ the product rule once again in order to figure out the equation of my tangent line. To find the equation of my tangent line, I need the slope of the tangent line, which is what the derivative tells me. So I want to find y prime at that particular value. So I do the derivative of this first part of my equation, which is 2x, times the second part, which is just sine x, plus the derivative of sine, which is negative cosine. Oh, wait, no, it's just cosine, no negative. Times the first thing, which is x squared. And then I want to put in that value because I want to figure out what it is going to be at 3. I don't care about the regular derivative. So no point simplifying this down without putting in that 3 first, because that's all I really care about. What is y prime of 3? So that's going to be 2 times 3, which is 6, sine 6, plus cosine of 3 is the cosine of 3. I don't know why I'm even thinking about that. Times that x squared, so that is a 9. So I actually plugged this into my calculator, and for extra confidence, I did the actual n-deriv version of it. You would do one or the other, but you can see that these two values are producing basically the same thing. They're off by a little bit, but that's way deep in the decimal, so I don't really care. So our derivative at this point is negative 8.063. Now it's just a matter of figuring out, okay, well, what is the equation for our tangent line? So we need y minus, I need a y1, so I'm going to type that into my calculator fast. That's 1.270. I'm just plugging that into the original equation because I need an x and a y value for my original to see where the original function is at that point. And then I'm going to slap on my slope of the tangent line onto it to make the tangent equation. So that is x minus our x value that we care about, which is 3. So this is the equation of the tangent line of y equals sine squared sine x at x equals 3. Bosh. In this example, I've done a little bit out of order. It asked me to graph the equation and its tangent line. I did that already, so there it is. That's what we're trying to create. We want to find the equation of the tangent line at that point. Finding the tangent equation requires a point and a slope. So I can get the slope by finding the derivative of f of x. So I've got to find that derivative. So I start with the derivative of the first, which is 3x squared plus 4, then multiplied by the second, which is x minus 2, plus the derivative of the second, which is just a 1, times the first, which is x cubed plus 4x minus 1. So this is f prime of x. But I just want to know what the slope is at a specific point. So rather than like foiling all this stuff and whatnot, why don't I just plug in the value that I'm looking for? Because I don't really care about the full derivative, just want the derivative at a certain point. So I just care about what is f prime of 1. So that is 3 times 1 squared. I'm just going to write a 1. Well, I'm even going to write that because it's just a 3. So it's 3 plus 4. And then 1 minus 2, that's going to be a negative 1. This one isn't doing anything, so I'm just going to leave that alone. 1 cubed is 1 plus 4 minus 1. So this is 7 times negative 1, which is negative 7, plus 4, which is negative 3. So the slope of my tangent line at 1 is negative 3. So the equation of my tangent line is y equals, oh, nope, not y equals, y plus 4, point slope form, equals negative 3x minus 1. That's the line that I graphed over here. We could check this with our end deriv stuff. Okay, all right. So I typed it all into my calculator. I got the d over dx. Here's the long version of it. You just can't see it all on the screen. And I got negative 3, which is about what I got. And remember, this kind of rounds a little bit. And then I also went to the y equals. I did a step farther. So I graphed y in this first part. And then I did the derivative of y1 at 1. And then I tacked on the extra stuff. So I did the x minus 1 once we get over there. And I did a minus 4 because I was moving this 4 to the other side. And when I checked the graph of that, boom, look at that thing be tangent right at that value of 1. Huzzah!